Hello everyone, my name is Stefan. I'm going to talk in this video about functions, lesson 1, because these functions are big, has a lot of information, so we are going to divide it more than one video so we can cover all the details. So first of all, what is a function? Function is something like a machine. What machine does? So a machine, you program it to do something. You may put, for example, wood, you give you papers. Machine to make something on, so it's programmed to do a function. That's what does it mean actually, like a machine. So for example, we have here this machine here. This is a machine. So what does, and this we call it f of x is equal x squared. So what this machine does, you give her an input. This is here input. So take it and give you output. For example, we'll take this machine, it will take number 1, put it in the machine and give you 1 square is just 1. For example, take -1, pass it in the machine and give you 1, because 1 square -1 square is just 1. Take 0, square it, give you 0. Take square root of 2, square it and give you 2. This is what a function does. Whatever kind of function, it will give her an input, so we'll give you an output, so applying whatever you ask her to do. In this case, what we say in this function, f of x equal 1 over x. So what we're saying it, so we'll give you a number and flip it to the bottom, put it in the denominator. For example, we give her number 2, took it and give us and she flip it, give us -1 over 2. Give her -1, take it to the machine, give us -1, because 1 over 1 just -1. We give her 4, so flip it and give us 1 over 4. Same thing here. Of square root of 2, we give her 0, give us 0, because just square root of 0 is just 0. Give her 1, give us square root of 1, just 1. Give her 2, give us square root of 2. Give her 4, give us square root of 4 is just 2. Same thing here, and this here is still a function, even if all the output, that we call it the domain, give us same output. All inputs give us one output. This is a constant function, and the graph for this function is something like this. It will be just a straight line, and this is 3. This is what this function does. However, we have a special case here. We see here that number 2, this is here not a function. Why? Because we see here number 2 give us 2 numbers. We give us here 4b and we give us c. Actually, is to be a function, each one input, it has to give us just one output. He can't give us 2. For example, this number 2, he can't give us more than 1. However, b, it can be output of more than one input. And here, this place here is called the domain. What is the domain? It's all numbers, doesn't matter how many, that it could be evaluated by the function. So when you put it to the function, he will accept it and give you an output, and the outputs are the range, so all the possible outputs that the machine produce by giving it the output, the input. So takes number from here, from the domain, and put it and give you the range. Take another number and put it, give you another range. So this all numbers are product of the function called the range, and what are we giving it is called the domain. This is what function is. So let's evaluate some functions. Let's start with we have a function f of x equal 3x squared plus 5x minus 1. Let's evaluate it in x equal 3, when x equal negative 2, and when x equal 1. And this is the function here we're going to evaluate. So let's start with the first one. So we have f of 3 is equal to 3 times 3 square plus 5 times 3 minus 1. You see what we did? We take the where we have x and we unplug the number that we are working for. We are going to evaluate the f of x n. For example, here we take the x and we change it with the number we are doing. So here is going to give us 3 multiplying 9 plus 15 minus 1 is just 27 plus 15 minus 1 is equal to is just 41. This is the first one. Let's do the second one. F of minus 2 is equal to 3 times negative 2 square plus 5 times negative 2 minus 1 is just 12 minus 10 minus 1 is just 1. So the third example, f of 1 is just 3 multiply in 1 plus 5 times 1 minus 1 is equal to 3 plus 5 is 8 minus 1 is 7. That's it. This is the only way you can do to evaluate the numbers. So let's do another example. We have this function here is g of x is equal 3x plus 1 over x squared plus 5x. So we're going to evaluate this function here and those three numbers here, and x equal negative 1, x equal negative 5, and x equal 4. So let's start with the first one. We have g of x is equal g of negative 1 is equal to 3 times negative 1 plus 1. When you have, for example, 1 just stays like this. Wherever you see x, you change it with the other number, times 1 square plus 5 times negative 1 square. So what is going to give us? Negative 3 plus 1 over 2 minus 5 is just negative 2 over negative 3 is just 2 over 3. Now let's solve the second one. G of negative 5 is equal to 3 times negative 5 plus 1 over negative 5 square plus 5 times negative 5 is equal to negative 15 plus 1 over 0. I did this for a purpose to show you when is a number is not inside the domain, what is going to happen. This is undefined, it can't be happen. So negative 5 isn't in the domain. So makes the function undefined. That's the reason why we have to make sure and we have the right domain, because if not we will be having a problems like this. I did that for a purpose. So let's find g of 4 is just 3 times 4 plus 1 over 4 square plus 5 times 4 is just 13 over 16 plus 20 is 36, and this is the what is going to give us the value evaluating the g of x when x is equal to 4. So let's now talking about the domain and the range. How we mentioned before, already mentioned it, that the domain is all the possible number that is possible to be evaluated by the function. Maybe there are some restrictions, you have to remove it, so you will not have problems as the problem we have before. Like here we can't evaluate the function, so we have to avoid those restrictions. For example, we have a function, we say we have square root of x. F, well, let's write it here. This is the domain, this is the function. F of x is equal square root of x. So we see if we put, for example, 0, we put it here, we'll accept it because 0 is inside the domain. It will come here and it will give us 0. If we put, for example, negative 2, it will put it here, it will come square root of negative 2, and this is undefined. So you have to make sure to have the right domain. And the range is no restrictions, just you want to know what is the value, possible values that the function can have. Could have infinity, from negative infinity to infinity. For example, if you have a function something like this, this is goes from negative infinity to infinity. If you have a function, for example, like this, you now is going from 0 to infinity. It depends of the function. You can look it up from the graph as well, make it easy for you. So let's find the domain and the range of those functions here. So let's start with number 1. Solution. Number 1. So we have f of x is equal x squared plus 3. We see from here that this function has no restriction. It's called second degree polynomial, and polynomial has no restriction at all. So the domain D is going to be from negative infinity to infinity, has no restriction, goes forever. So what is the range? We see here is going to infinity, we know that. So we have it's going to infinity, and we have this function is actually written like this, is something like this. So what is going to give us, we know this function is usually, if we take function x squared, is something like this. But we have x squared plus 3. So what we're going to do, just shift this function 3 to the top, because when x equals 0, f of x is equal to 3. So we can shift this function here to the top 3 point here, 1 1 2 3. So just move this here, pull it up 3, it will be like this. And this is the graph, not this one here, is this one here. This is just f of x equal x squared. This is x squared plus 3. So this is, will be, we see from here, this is 3, so it's going from 3 to infinity. So the range is equal to 3 is included, 3 to infinity. Let's do number 2. Number 2, change the color so we don't mix them. So what we have f of g of x is equal 1 over x minus 1. So we see here we have a restriction. What is the restriction we have? The bottom, the denominator, let's change this color. This here, the denominator, it shouldn't be 0. Why? Because 1 over 0 is undefined. So let's see. So we have x minus 1 couldn't be 0, therefore x, it couldn't be 1. So this is the only restriction we have in this situation. So what is the domain? Therefore d is going to be from negative infinity to 1, united with negative with 1 to infinity. This is the domain. Let's find the range. Range, it will be equal to, we see this here is something like this. It's called a hyperbola. So how that will be written? We have this function is not defined in 1, so we take 1 here. So this function, it will be something like this. It will be something like this. And we see when you have a function like this, a rational function, and you see the power here of x is bigger than the power here of x in the top, and the power in the denominator is bigger than the power in the numerator, so it will be it will be 0. So it is going to be to 0 here. So how we see here this function, this will be like as asymptote, this one here. So this function is defined from in negative, the range will be from negative infinity 0 with 0 infinity. This is the range is going to be for this function. So let's do the third one. So the third one, we have z of x is equal to 1 over square root of x minus 4. So in this case, we see we have two restrictions. This 4 x minus 4, it shouldn't be 0, and in same time x minus, no, square root is x minus 4, it has to be bigger than 0. Bigger or equal to 0. So let's solve the first one. So it will be not equal to 0, therefore let's go with this first one here. So it will be x minus 4 is not equal to 0, therefore x, it has to be not equal to 4. So let's do this second one here. We have x minus 4 has to be bigger or equal to 0, therefore x has to be bigger or equal to 0. So in this case we see that x, it has to be not equal to 4, and x, it has to be bigger than 4. Therefore we see we can just move this because it's not included here. So therefore r is going to be negative infinity to 4. I want to say from 4 to positive infinity. So we will be from 4 to to infinity. This is the domain. So let's find the range. The range of this function, and we have the power here is bigger, is going to be 0. So the function here is the domain is from, the range is from negative infinity 0 with 0 infinity. So it's going to be. Please subscribe and thank you for watching.